So, hey guys, welcome to High Entropy, and it's another weekly grind, weekend grind, and we are going to solve DSA problems. So, welcome to live stream, and let's begin without wasting time. And right now, like I'm using my webcam, so might be video quality is not good, because I'm sitting on uh, bed right now, and I just thought to create another kind of series where I will comfortably sit and grind DSA for few hours. So today let's target to solve until like at least 2 3 hours. Let's do spend here, and then tomorrow I have to wake up early. I mean, for me it will be early because 8 a.m. is early only for me, and because there will be one weekly lead code contest and I need to participate in that contest. So let's begin. Let me change my screen and you can see it. Correct. Correct. Hmm. So, okay. Let's go to take you forward and start push. So, graph, topological sort, find eventual safe state. Yes, we have to solve this problem. Given a directed graph with v vertices labeled from 0 to v minus 1, the graph is represented using adjacency list where adjacency of I denotes node adjacent to node I. Yeah, that is normal thing. Meaning there is an edge from I to each node in adjacency. That is also a node is terminal node if there are no outgoing edges. So for example, outgoing edges. That means it's all of them are in degree, no out degree from it. So 5 is an terminal, is a terminal, not in a is an terminal. Return array containing all the safe nodes of the graph in ascending order. Okay, graph nodes should be in ascending order, but forget about ascending order. Okay, this is one thing here. 0 1 2 3. 3 is terminal node because all the nodes, like there isn't any outgoing edge from it. Hmm. So 3 is terminal. 2, I'm not sure why they are calling. Actually, I tried it at yesterday as well last time, and I found one thing here. That all the nodes that are participating in a cycle are not, excluding those nodes. All of them are sit. I'm yawning right now. Maybe I'm using more brain. Okay, so oh shit, network speed is very slow. No worries. Let's continue. So 0 1 2 3. First, I'm just thinking how it fits into topological sort. What should I do here? First thing, there is cycle. That is 0 1. 3. A node is a terminal node. A node is safe node if every possible, oh sorry, if every possible path starting from that node leads to terminal node. Okay, got it. This part I missed. If every possible path starting from that node leads to a terminal node. So that's why from here this one will lead to terminal node here, but this one 0, 1, 2, 3 and 0 coming back to 0. So basically what we say, so these are the nodes. Now see, terminal nodes are this one is terminal node, this one is also terminal node, because nothing is going outward direction, all the nodes, no, nothing is here. But here for 0, let's start for 0. So from 0 to 3, 0 to 5, 0 to 5 you are able to get into this node, right? But from here you have another path, that is 0, 1, 3, 0, 1, 3 and 0. This is not a safe path, so you won't consider this node. For 1 also it will be the same. So 0, 1, 3, all these nodes won't be part of it. So can I say all excluding all the cyclic node, not cyclic nodes, all will be uh, safe node. But how to detect cycle? I mean, detecting cycle is different part, but here finding all the nodes in the cycle. Let me just think in topological sort way. Topological sort. How will it help here? Hey bro, just do it. Okay, I mean I need to set up 0, 1, 2, 3, 4, 5, 6. Topological sort, there are two ways, BFS, DFS. What we were doing in BFS, DFS? In BFS, in degree concept, DFS explore everything. in explore everything. So all the nodes from non-visited node start, and when I'm revising depth first search, for example, you will start from 0, 1, 2, 3, and push it into stack. Start taking out each item. This is the process here, but how will it help? It is for this is for a cyclic, so it won't work here. Let's say we started from 0, so DFS of 0 will call its dependent one, because those tasks will be complete should be completed before it. So DFS of 0 will call DFS of 2, and DFS of 2 will call DFS of 5, and okay, this is one thing. And now after DFS of 2 you will call another one, DFS of 1, and it will call DFS of 3, it will call DFS of 1 again, sorry, yes, DFS of 0, DFS of 1, 3, I mean, yeah, what's wrong with me? You call DFS of 1, DFS of 1 call DFS of 3, DFS of 3 will call DFS of 0. And here, so we can say like this branch is trying to access the same node again. this branch, this part 1. So I don't know how to solve it. You still I'm not able to figure out how can it be solved. How can we solve it using the topological sort? I what I think is the same thing. I mean, what we will do? Simply, we will start from here, and we will store it somewhere in the stack. Now, so for example, here you are trying to again call 0 DFS of 0. So what you will do? Basically, you will append into stack like, okay, I tried to call 0, and what it will do? Now again, now you will say, okay, you will return it to this, and it will say, okay, do you try, or have you tried to call? No, it will say no, this one. So from here onwards, you will say, you will get. So what you will do? Simply, you are trying to call a visited node, but if it is visited node, that is okay. But here you are trying to call the same node that is part of stack. So visited plus, okay, so if node is visited, simply you will append it into it. For example, you try to call 0. So 0 you will append and you will return. From here it you will return 3 not visited this. So you will return at then 3. Very vague. In that way I need to track two things. I mean, I just need these nodes as well because these will won't be part of topology. No, it won't. Any other approach? Bravo. Let me do one thing. I will watch tutorial first. Tutorial. Sometimes it's better.
What is the problem state? The problem state is given a directed graph of B vertices and E edges, and the graph is a zero-based vexing graph. A node is a terminal node if there are no outgoing edges. So there should be incoming thing. Might be incoming.
What's wrong with it? It is not detecting if I'm sharing my screen. Holy small is it? Seems like my screen share is not working. Let me just check. Bro, my screen share was small is it? Seems like my screen share is not working. Yeah, not working, bro. See, it is showing same. Still, I'm not able to figure out how can it. Okay, let me just toggle it. Maybe it will work. No, no, no. Now it's working, right? Yeah, it's working. Sorry for the inconvenience. Is it working? I think yeah, it's working. Better, far better. Wow, it's working. Sorry for the inconvenience. Is it working? Oh, let's do one thing. Yeah, it's working. Now screen share is working. Let's go back to the video first.
Then we call that node as a terminal node. A node is a safe node if every possible, very, very important point, if every possible path starting from that node leads to a terminal node. Okay, now you need to return me an array containing all the safe nodes of the graph. The answer should be sorted in ascending order. So what does the question state? So this is the given example. They're asking you, out of this, which are the safe nodes? That's what you need to figure out. What is a safe node? Every path, very important. Every path ends up at a terminal node. Ends up at which node? A terminal node. What is a terminal node? No outgoing edges, or you can say out degree of that node is zero. So in this video, I'll be solving this using the cycle detection technique, and in the next video, I'll be solving this using the BFS or the 2% technique. So in this video, you need to be knowing about cycle detection in an undirected graph. If you haven't seen, you can go back like 3 or 4 videos in the series, you'll get that video. So out degree has to be zero. So can I see this guy has one outgoing edge, but this is definitely not a terminal node. Can I say this has no outgoing edge? I can. And can I say this is a terminal node for me? I can. So first terminal node I can spot is 6. Do you spot any of the terminal nodes? Yes, you do.
Let me keep my
As incoming, but no outgoing. So I spotted one more terminal, which is 5. Do I spot any further terminal nodes? I do not. I do not, because everyone has an incoming and an outgoing edge as well. So let's start with 0. Let's figure out the first path. 1, 3. So it redirects me back to 0, not toward any of the terminal nodes. So 0 cannot be a part, or 0 cannot be called a safe node. Let's try out with 1. 1 goes to 3, 3 goes to 0, 0 comes back to 1. So 1 can also not be part of a safe node because it comes back to himself, or it doesn't, like all the paths do not end up at the terminal node. Let's check out 2. 2 has only one path. If you can see 2 has only one path, and that ends up at 5. 2 has only one path that ends up at 5. So can I see this? Yes, can I see this? That 2 is a safe node. I can definitely see that 2 is a safe node. So 2 is a safe node. Let's check out 3. 3. One of your paths is definitely ending up at the terminal nodes, but are all the paths? Let's check. 3 has one more path like this, and like this, which ends up at the 3 himself. So you can definitely see 3 cannot be a part of it. Can I have 4 as a part of it? Yes, it does end up at a terminal node 5. So 4 can also be a part of my safe node, right? Let's check out for 5. 5 is himself a terminal node, which means it's a safe node. So 5 is a safe node. Let's check out for 6. It's a terminal node, so a safe node. So I can say this is the array in the sorting order which you have to return as answer. So you have to figure out all the paths, and if all of the paths end up at a terminal node, then you say that, okay, that guy is definitely a safe node. So the question is very straightforward. Give me all the safe nodes present in a graph. So do you remember the cycle test where we detected a cycle? So can I say, by observing this particular example, we did figure out that all possible paths are going to end up somewhere. But if they return back to themselves, like there was 1, 3, 0, right? These 3 were the part of the cycle, and they can never be safe nodes. Something to observe. Anyone who's a part of the cycle can never be a safe node. So imagine if I have a 7, which is pointing to 1. Will 7 be a safe node? No. Why? Because 7 can have a path through the same cycle and end back at not a safe node or not a terminal node. So what you can say is, everyone who's a part of the cycle, you carefully observe, everyone who's a part of the cycle, everyone who's connected to the cycle, you can say everyone who's a part of the cycle and everyone who's connected to the cycle will never be safe nodes. And if you look at this, this is not having any incoming edges to the cycle. No incoming edges to the cycle. Thereby, it will always end up at terminal nodes. If there's a cycle and anyone who's connected to that incoming edges, so it will turn back on that stuff. So you cannot end up at a terminal node. So a slight observation we have noticed is, anyone who's a part of the cycle, anyone who is a part of the cycle cannot be a safe node. And anyone that leads to a cycle, anyone that leads to a cycle cannot be. So I have figured out 2 ways. Apart from them, everyone else can be a safe node. I can definitely say that, right? So the whole problem can be easily solved by figuring out which guys are a part of the cycle and which guys are incoming to the cycle. That's what we need to figure out. Once we figure that out, I think we should be able to solve this problem very, very easily. So as of now, you know both the points, right? So we've already learned how to detect a cycle using the DFS technique, and if you do not know, please go back and watch it. And over there we used a couple of arrays. One is the visited and one is the path visited, right? That is what we used. So we're going to do the same thing, and we will run the same thing on this particular algorithm, and we will see how can we figure out which is a cycle and which nodes are approaching the cycle. So we learned cycle detection in the previous videos, right? And over there we used a couple of concepts. One is the visited and the other one is the path visited. Now over here we are going to apply the same concept, and we are going to determine which are the safe nodes. So as of now for this particular graph, what you can do is you can draw the corresponding adjacency list. So this is how the corresponding adjacency list will look for this particular graph. So what we will do is, if you remember, we had a couple of visited arrays. So we will create both the visited arrays and assign them with 0. So let's create both of them. Okay, so as of now what I've done is I've created the adjacency list. as well as I've made the visited array and the path visited array as well. So remember, all of these are assigned with zeros. So let's start the DFS calls. Again, since this can have multiple components, we will start the DFS in the standard way where we write I equal to 0 and then go for V and then we say not visited. Then we call the DFS. Remember this? So that's what we will do. The very basic standard way if there are multiple components. So which is the first one? It will go from 0. So let's start from 0. So you're starting from 0. This is where we are. So we will start the DFS call from 0. So let's start the call from 0. The moment you add 0, what you will see is, okay, here is uncertain. This call gets completed. Uncertain. This call gets completed. Then only I'll call it as a safe node. And if this call gets a cycle anywhere in the path, I will not call this as a safe node. Got it? So let's start. So DFS of 0 says, hey, listen, I'm visited, I'm path visited as well. I'm visited and I'm path visited as well. Next, it goes to the adjacent, which is DFS of 1. Right? This is the adjacent node. This is the adjacent node. Goes to it. And as of now, says visited and path visited. 1 will now go to 2. And when it goes to 2, it says visited and path visited. 2 will now go to 3. So when it goes to 3, it again says it as visited and path visited. Remember this. Starts from here, goes here, goes here. That has two options. Either it can, from 3, it has two options. Either it can go to 5, either it can go to 4. So 3 goes and checks who's the first in the adjacency list. So the first it finds is 4. So it will go to 4. Remember this, it will go to 4 and then it will come back and probably go to 5. But that will be done in a later stage when the recursion is complete. Recursion classes, guys. So DFS 3 to DFS 4. So we will go for 4. 4 is visited, path visited as well. Next, 4 will go to 4, 4 will go to 6. So let's go to 6. DFS of 6. Again, it will mark 6 as visited and path visited as well. Now 6. It's a very important point. 6 is pointing to 7. 6 is pointing to 7. So it will call for 7. It will call for 7. And it will mark it as visited and path visited. Visited and path visited. Now, when you go to 7, it states, hey, I do not have anyone. I do not have anyone to further call DFS. So I'm like, yeah, wait a second. No. We actually reached an end. We started our journey from here and we reached an end. Can I say every node in this is a safe node? Because you started a journey, but wait, there's one more part to be checked. Fine, we'll check it afterwards. But as of now, can I say, from 6, there's one outgoing edge which ends at 7. And 7 is a terminal node where I'm standing at. So from 7, there cannot be a further DFS call. So can I say 7 is definitely a safe node? I can say it's a terminal. So what I'll do is, I'll just mark 7. You can use any map or third array. You just keep a mark, which is a check. So I say everything for 7 is done. No further DFS calls. So this is a safe node. Mark it as true. Alright? What's the next thing that we'll do? What we'll do is, okay, we'll mark it as true. Next we'll come back. Let's come back. Now 6 says, I had a call for 7 and I ended. I don't have any further calls. Why? 6 only has 7 to go. Fine. DFS is over for 6. No further calls. This guy is also a safe node. This guy is also a safe node. Mark it. And remember, when you are returning, the path visit will go as 0. The path visit will go as 0. So now return to 4. The 4 says, I don't have any further calls. I just had for 6 and I did it. I'm back. 4 doesn't have any DFS calls. 4 is also a safe node. So mark it as true. Oh, why am I going up? Mark it as true. And at the same time, make sure 4's path visit is done because 4 will now go back. So now 3, which went, cannot call it as a safe node. Cannot call it as a safe node as of now. Why? This is one more path which he has to explore. What does safe node means? All the paths should end up at terminal node. Over here, 3 states, one path ends at a terminal node. I have one more path to figure out, does it end at a terminal node? I have to figure that out, right? So that is what we'll do. We'll start from 6 now. Sorry, 5 now. So we'll go to 5 and we'll say path visited, path visited. Now 5 goes to 6. 5 goes to 6 because 5's next node is 6. But the moment you go to 6, you actually say, hey, wait. 6 is already visited. 6 is already visited. It got visited in this direction. And if 6 is already visited and I did not get any sight, 6 is visited, but 6 is not path visited. It's not in the same path. It went in this path, now it's this other path. It's not in the same path. It's definitely not a cycle. And if 6 has been checked and we did not get a cycle, I will no more go and check for 6. I'll no more go and check for 6. And I'll be like, fine, I don't need to check for 6. So I don't need to do a call because 6 has already been checked. If you carefully see, 6 has already been checked and it did not get a cycle. So I will not do because 6 is definitely not a cycle. Why? Because it was in a different path and this was in a different path. 6 is definitely not a cycle. Because if it was a cycle, it would have gone like this. So it is not a cycle. It is not a cycle. Can 5 do any further DFS calls apart from 6? No. So I'll say 5 is a safe node. I'll mark 5 is unvisited and I'll go back. Now 3, explore this path, explore this path. Can I say for 3, it explored both the paths, which eventually means it is a safe node. So I'll mark 3 also as a safe node and I'll now go back. Going back, make sure this is 0. 2 says, I'm also a safe node. So 2 marks itself and goes back. 1 says, I'm also a safe node, marks itself and goes back. 0 says, I explored all my paths. I'm also a safe node, marks it as 0 and goes back. Everyone, the path has been traversed. We did not get a cycle. But this path does not have a cycle and everyone ends at 7. If you see, everyone ends at 7. So thereby, all of these nodes can be called as a safe node, right? So everyone done. Now this will change to 1, to 2, to 3, to 4, and it finds everyone is visited, which means they have been checked. There's no need to check again if they haven't been checked. So what I will do is, I'll now go to 8, and that's when we find it as unvisited. We will go to 8, and that is when we find it as unvisited. So what I'll do is, I'll call DFS for 8 now. So I'll just quickly raise this up, because the next call will go for 8, right? So as of now, we have a DFS call for 8. So let's start the DFS for 8 now. So I start the DFS for 8. When you start it for 8, you mark them as visited and path visited, right? 8 has a couple of them, 1 and 9. So 1 and 9. So as of now, can I see this? 8 goes to 1, right? But will you go to 1? That's my question. Will the 8 call a DFS for 1? No. Why? So when 8 tries to go to 1, it says else, I am already visited, and I am not path visited. which means I'm not a part of a cycle, or I'm not someone who gets into a cycle. Because if this guy was a part of a cycle, he would have been visited and path visited as well. Got it? It's not a part of the cycle. Because if you would have encountered a cycle like this, the moment you encounter a cycle, I would have returned. I would have returned. So the path visited for this guy would have also been 1, because anytime you get a cycle, you break and return. You do not reset the path visit. You only reset the path visit if and only if you did not get a cycle. Got it? Cycle detection video. So 8 states, 1, it's just visited. You did not get a cycle. So fine. This path is safe. I'll not call it, but this path is safe. I still have a path to explore, which is DFS of 9. Let's explore. So I go to 9 and I say fine. Visited path visited. 9 says I go to DFS of 10. 10 says okay. Visited path visited. 10 says the next guy that I have is 8. And that guy is saying visited. Path visited, which means false. Which means false. So this guy cannot be a safe node, because 10 encountered an 8 cycle cannot be safe. Thereby, it doesn't remarks it itself as 0. Doesn't. It just goes back. It just returns. The moment you get a cycle, you return. Do not reset. 9 says you got a cycle. 10 got a cycle. Return. 8 says you guys got a cycle. I'll return. No one unmarked themselves. So all of them are marked as visited and path visited. The thing that I was explaining. Everyone returned and none of them were safe nodes. Perfect. So we're done with this. Next, this will go to like 8, 9, 10, that's 11. At the moment you try for 11, see what will happen. 11 says I have a 9.
What the heck?
I counted an 8. False. Which means false. So this guy cannot be a safe node, because 10 encountered an 8 cycle cannot be safe. Thereby, it doesn't remarks it itself as 0. Doesn't. It just goes back. You just return. The moment you get a cycle, you return. Do not reset. 9 says you got a cycle. 10 got a cycle. Return. 8 says you guys got a cycle. I'll return. No one unmarked themselves. So all of them are marked as visited and path visited. The thing that I was explaining. Everyone returned and none of them were safe nodes. Perfect. So we're done with this. Next, this will go to like 8, 9, 10, that's 11. At the moment you try for 11, see what will happen. 11 says I have a 9. The next one you try to go to 11's neighbor, which is 9, it says I'm visited and I'm path visited, which means I got a cycle. That's why I'm still path visited. Because someone returned. Someone did not unmark me. Thereby, this is also not safe node. Eventually, you have marked all the safe nodes and you can just store them. Very simple, very straightforward. Okay, so guys, I hope you understood the explanation. At the moment I will start coding the tree, all just that's step 11. At the moment you try for 11, see what will happen. 11 says I have a 9. The next one you try to go to 11's neighbor, which is 9. This path is safe. Why? So when 8 tries to go to 1, it says hence I am already visited. I am already visited and I'm not path visited, which means I'm not a part of a cycle, or I'm not someone who gets into a cycle. Because if this guy was a part of a cycle, it would have been visited and path visited as well. Got it? It's not a part of a cycle. Because if you would have encountered a cycle like this, the moment you encounter a cycle, I would have returned. So the path visited for this guy would have also been 1, because anytime you get a cycle, you break and return. You do not reset the path visit. You only reset the path visit if and only if you did not get a cycle. Got it? Cycle detection video. So 8 states, 1, it's just visited. You did not get a cycle. So fine, this path is safe. I'll not call it, but this path is safe. I still have a path to explore, which is DFS of 9. Let's explore. So I go to 9 and I say fine, visited path visited. 9 says I go to DFS of 10. 10 says okay, visited path visited. 10 says the next guy that I have is 8, and that guy is saying visited, path visited, which means false. Which means false. So this guy cannot be a safe node, because 10 encountered an 8 cycle cannot be safe. Thereby, it doesn't remarks it itself as 0. Doesn't. It just goes back. It just returns. The moment you get a cycle, you return. Do not reset. 9 says you got a cycle. 10 got a cycle. Return. 8 says you guys got a cycle. I'll return. No one unmarked themselves. So all of them are marked as visited and path visited. The thing that I was explaining. Everyone returned and none of them were safe nodes. Perfect. So you had in a much better way. So I'll go to the detector cycle.
So it's a new one. Oh, sorry. Let me check if someone will ping me. I will get text at least. So what I'll do, I'm taking a lot more time in this problem. Okay, no problem. Let me start. Yeah, I'll keep it here. First I'll draw and I'll get the idea. Come on, where are you, bro? Yes. Let's take the same example and we'll draw it. So we have this graph. So what I'll do, simply I'll create 2 arrays. Why don't I clean it everything? So what I'll do, simply I will create two things. So visited, and there I will keep everything. Visited and path visited, or you can say path visited. And what I'll do, simply I will create another array, and I'll mark whether it is part of 2, 3, 4, 5, 6, and 6 only till AM. So everything will be marked as 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So many zeros. So we'll start from any node. So I will start from 0 to 0. So I will take 0. So I will mark 0 as a 1. It's a visit. Okay, so when you are visiting from a node, so you will call like DFS of 0, and it will mark it as a visited, and then it will call, okay, DFS of 1, or it has two options, DFS of 2 and DFS of 1. So let's say adjacency list has two, both DFS of. So what you will say, 0 is marked visited because 0 is part of our visited path. Now you will call DFS of 1, so you will mark this one, and at each node you will check whether it's visited or not visited. If it is not visited, mark it visited, so you will mark visited, and you will say okay, it is part of it. And when you will say okay, now you will call DFS of 3, and what you will do, so DFS of 3, and you will mark this as a visited, and you will mark, sorry, this one as a part of path. So that's why you can say 0, 1, 3, these are path visited, or these are the paths part of existing exploration. And then you will try to call from 3 to, you will call DFS of 0. So you will say, oh wait a minute, it will say, bro, DFS of 0 is already part of path visited, and also it is visited node, visited, and so visited and path visited. Then you will return simply false, and you won't reset anything. Correct, because these are part of cycle. So you will say okay, this one is path visited, this is path visited, this is path visited, and these nodes are visited. Okay, so you will say okay, DFS of 0, 3, and you will return the same here and same here. So at the end you will get it like this. Now you will start exploring from 2. Okay, so now you have 1, 3. So 1 is visited, 2 is visited. Okay, so 1 is visited, 2. Now you will, so like it's we starting from all the nodes 0, 1, 1 is visited. Now you will say 2. So from 2 you will check again, and you will say okay, let me call DFS of 2. Okay, so you will call DFS of 2, and what you will do, so DFS of 2 will call, simply you will mark DFS of 2 as a visited, and also you will keep it in path visited. Then you will go DFS of 5, right, you will go to DFS of 5, and what you will do, so this is one component of graph, or you can say this is one part that is accessible, and another part that is not accessible by this source. So wait a minute, I think I missed something. Yes, when you are exploring DFS of 0, DFS of 1, DFS of 3, DFS of 0 again. So you got false from this branch, DFS of 1. From it you will get, sorry, so you will get false. And now you have another branch, don't forget, this is another. Now you will call DFS of 2, and DFS of 2 will call, so you mark 2, DFS of 5. Okay, so DFS of 5 doesn't have any nodes to explore further. So what I'll do, it will return true. I mean, let's do one thing. Yeah, it will return true, and it will return true. And what will do, if it does not have anything, that means you can mark it as a, it is done. So 5, here you kept path visited, and here you kept visited, correct? And after that you will, what will do, so this is a true node. So I mean, this is the node that is basically not contain, that does not contain any cycle based on it, because you are not able to explore further, and this node is, you are able to reach, so you'll return true. From here you don't have any further path from 2, so you will say okay, this one also will be true. So from here you will say true. Okay, so you will store the result as well. 5 you will store, then you will store 2. And for this, if you are getting cycle from any part, so from this part you will get true, from this part you are getting false, from this part you are getting false, from this part you are getting true. If any one of the part having false or cycle, then it cannot be part of, so this one won't be part of it. And now you will check 4 and 6, there is a 6 node, I forgot to write, even I kept 6. So for 4 you will just say 4, DFS of 4, and you will call, and you will see, end up with DFS of 5. Just let complete it. So DFS of 5 you will say okay, it's already visited. And also when you are returning back, you are marking them visited 0. So that's why you will say for 2 also you will mark 0. So you will say DFS of 5 is visited, already visited, and it's not path visited, so that means it's already completed and it's okay, safe. So you will say DFS of 4 true, and you will store it into the, into this part result array. And now you will say 6, so 6, DFS of 6 you will call DFS of 6, and 6 does not contain anything, and so it's not part of visited or something, so you'll return, store it into the result array 6. Okay, this is one of the approach. Wonderful. Let's solve it. What I'll do, I'll keep it aside and let's solve it using DFS. Then I will watch video. I might be, because I needed to watch video. I think the cycle detection I haven't solved it using the I haven't watched the video basically. I still solved it using my approach. Good, that wasn't efficient, but it's okay. So first thing, I will create one visited array, and here I will mark everything 0 for underscore in range v, and here you will mark visited, and another I will create, copy the same path visited. So these are the nodes. Now next step is just we have to create a function DFS. DFS self, and you will pass a node, you will pass adjacency, visited, path visited. Okay, so now from a node, what is the thing, you are at a node, now you have to check all the adjacent node. So neighbors neighbor for adjacency of node. So you will look for neighbor. If not visited, then what does it mean? You can call further, correct? If not visited, NBR. Simply call uh, result equals to DFS self.dfs, and here you are going to call neighbor adjacency path visited, and what you will do, you will do two things before it. First thing, visited of I, not sorry, neighbor will be 1. Basically you will mark 1, this node is visited. Also you will mark path visited of neighbor equals to 1, because this is part of it, this will be part of path visited, and then you will call. And after the result, so after the result, what needs to be done? Okay, I'll do one thing. I will say global result. This is, I will pass it here as well. So global result, if this is the condition, okay, so if result is true, that means uh, yeah, that means okay, it's this is okay branch. So what I'll do is, if result is okay, then simply I will keep result false. False. No. I will keep true. That means it is okay. But if I if result, that means you are getting true from this branch. So for this node, this is not a part of cycle. For okay, 1 minute. Yeah. So this node, you already explored all the option from this neighbor or this node. So you can say if result you are getting, that means okay, you will do two things. Basically you will mark path visited is of neighbor equals to 0. That means you are resetting the path, and also you will do one more thing, that is result equals to no, result is okay. Here you will do path visited 0 and global result dot append, and you will add neighbor into the result. This is one thing. Okay, else if it is not the, then you will say result equals to false. At any moment you are getting, so I'm just keeping global result that you are going to return will be false, because if you are getting from any branch for this particular node, then it will be false, like this will be part of cycle, and result will be false, and you won't reset it. Okay, this is one thing. Else if it is, if not visited, and if the node is visited, okay, just 1 minute. If node is visited, okay, one more thing, if node is visited and it is part of cycle, some other cycle, that is also issue, right? So you will say else visited, and if path visited of neighbor equals to 1, what does it mean? Result equals to false. That means for this node, this neighbor is causing the issue. So definitely you will say for this node for sure This is a part of a cycle, so it won't help. Okay, at the end, so this is one thing. At the end, you will say return result, whatever result you are getting from it, true or false. If you will get know where you are getting something, then you will it will be true. So this is result, global result. Hmm. And now I will call here for node in adjacency, no, in range v, if not visited node. So simply you will call result equals to self dot dfs, and you will say node adjacency list you will pass, visited you will pass, and path visited you will pass, global result you will pass. Okay, so this is one thing, and you will mark visited of 5, sorry, node equals to 1, and also you will do one more thing, equals to 1. If result, then you will say path visited. So you are repeating the same step because it is needed for different components of it. Path visited dot append, and you will say node. Also, what you will do, path visited node and path visited of, no, sorry, global result dot append, path visited of node equals to 0, resetting the node, but uh, but but if you are going to do this, and at the end return, uh, I will do this, return reversed and global result. No, I remember global result dot reversed will give me wrong result. So global result dot re, reverse. Huh? Where I did this? Set. Adjacency, node adjacency visited, path visited, bro. Where is the? Oh, come on, man! What you did? Node, you reset. What's wrong with me? Global result is missing. I should do yoga now. Oh, sorry. Why did you do reverse? Ah, crazy. Short. Still, your answer is incorrect. 0123. Really? That means logic fail somewhere. You will call 0. Visited node. Bro, where is the wrong top? Where is the issue? Sometimes I feel like I take things in wrong way. Result true for neighbor in adjacency node. So I will get 0. From 0 I will call its adjacent node 1. So neighbor if not visited. So 0, 1 is not visited. So visited neighbor, you will say mark 1. Path visited 1. Here also you mark path visited of node 1. Then you call, and at the end you will get result. Global result dot append node. If not visited, visited equals to 1, was visited self. You got this. If result true, that means this part of node uh, is not a part of cycle because you completed all the nodes for this, and so you will say result global result dot append neighbor. Else means it's visited. uh, okay, it's visited and you are again trying to access it from another node, and this is one of the visited and its path visited neighbor is equals to 1. Where is the issue then? Let me just do one thing. I will call 0 only. Let's see. Just wanted to see. And just it will be like calling one node only. Still see I'm getting 0, 1, 2, 3. 0, 1, and from 2 you are calling 3. So 3. When you will call 3, it will return true. Wow, how 2 will react? This is one of the. So you call 0, let's say it call 1, it call 2. So 2 is going to call two things. 0 call 1, 1 calls 2, 2 calls 3, 3 returns true. When 1 will call to 2, the man goes blank. Where I missed card? Something I missed. Now I'll stare at the code. Staring at the code won't help me. First thing, let's think. You will start from 0. So you will call 0. 0 visited will be 0. Okay. If not visited, 0 is not visited. So you will say okay 0 visited. Make node 3 visited. Path visited 1. You will call result self.dfs node. Adjacency visited, path visited, global result. Now you will call 0 will call. Okay, so here you will get 0 as a node, and now 0 will call. From 0 you will look for neighbors. There is 1. So what will do? Say neighbors of 0. 0's neighbor is 1. So 1 will be called here, and if not visited neighbor 1, so you will say neighbor 1 path visited neighbor equals to 1 result self dfs 1. You will call 1 and it will wait for again. So you will go to 1. So 1 will come here and 1 will look for its adjacent. So it will call 2. So 2 will check. So here suppose you are getting at 2 nodes 2. Now what it will do? It will check result you kept true, but you will wait all the neighbors of 2. So you will see 3, and you'll see 0. There are two nodes. So 0 is already marked visited and part of path visited. Okay, so far. So now neighbor in, okay, so you are at 2. So you will call 3. So what will happen? 3 will return. Okay, so here if you will call 2 and you will call, so 2 has two options, 0 and 3. So let's say it called first 3. So for 3 you will come here, 3 will say return true. So for 3 nothing is there, no adjacency nodes. Wait a minute. Okay, so 2 will call 3, first 3. So 3 will come here, so you will call 3 and 3 doesn't have anything, so you will return result. So that means it will return true. Now 3 you will get return true. So for 3 you will mark like, okay, path visited, you will reset it and you will reset it as well, and you will mark result path visited neighbor equals to 0. Append neighbor, neighbor means this one 3, else result false if not visited. Else suppose it is visited. Okay, if path visited neighbor equals to 1. For me, you think looking good. How much time I'm speaking? Sorry, bro. I was not looking into the chat. Yeah, bro. Definitely, I'll help if I can. Yeah, bro. Definitely, I'll help if I can. Laggy brain, bro. You are like me. I don't know. I feel my brain also sometimes start lagging. There we go. Laggy brain, bro. You are like me. I don't know. I feel my brain also sometimes start lagging. I'm not looking into chat. That is the problem. I'm just looking for something where I can see chat on pop up. Let me close it first. I will focus on some. I think I missed one point. I don't know how I'll survive tomorrow because a lot of things I have to do, bro. Okay. Oh, where is my mic? Camera action. Few ping seconds. Entropy, bhai. Oh God. For nobles in this, what? I missed one point something. I don't know. where I did mistake. Let me just think. When you will call 2, this is the point that should give something. Maybe I missed one corner case, and because of that it is returning true, and because of it something. Yeah, I think so. For example, if you are at 2, so you call 2 here. Imagine you call 2. I'll do it right, bro. I don't know what's wrong. I'll call foggy brain. You call me lazy brain. Sorry, just kidding. So suppose it is calling DFS of 2 and DFS of 2. So DFS of 2 will try to call DFS of 1. Sorry, DFS of 3, and DFS of 3 will just visit here, and 3 doesn't have any neighbors, so it will return true. True, correct. And now DFS of 2 will call DFS of 1. No, not DFS of 0. So DFS of 0, what it will do, DFS of 0, and you will see DFS of 0. DFS of 0 is I will do one thing, print node and result visited, path visited. See, it is returning true for 3 1 1 1. For 2 it's reset 0. That means result got somewhere true, converted into true. Visited neighbor. So actually I'm just debugging, I don't know, something somewhere. I'm just returning the result, and that is the causing the issue. I missed one corner case, I think. So visited neighbor, and the neighbor will be NBR, and for that Oh, so it's not going into visited neighbor for 2. Neighbors of node. IDC of node. Where is the issue? Neighbors of node 1. Neighbors of node 2. 0 and 3. This is very bad debugging skill. I think I made one mistake, some silly mistake, and I don't know what's wrong with it. Marking false for 2. I think one problem will be there. If it's related to global or some variable, then I will. Oh, so many. Something is wrong. Anything? No. Okay, it's better. I mean, sorry. Has anyone pinged? I mean, you got the result from the neighbor 0. False. How it's possible you are getting true from one neighbor, another from. Oh, sorry. I just made one mistake. I'm just checking. Is it because of global or local variable, non-local global something? Or 2, not 2, and neighbor 3. Then how am I getting true for 2? at the end. Where did I make mistake? Sit. Bastion. And show. I mean, yeah, bro, I got it. I mean, crazy. One wrong local result. This variable I'm already resetting every time. So how can it be result? This is the final result, and I just did something crazy. Oh, is there something wrong? I feel like something I printed. Oh yeah, print is the issue. Any other print? Basically, if you are using multiple print, somehow it's take there is a memory constraint. So it was a logical error, not this coding error. Oh, if you ping, no, no problem. Hmm. So I feel like I won't watch another tutorial of it. I will park it for later. Park the BFS approach, but make sure don't make the same mistake again as what I did. Reassign the same variable will, and because of it global result impacted. Alien dictionary. Wonderful. Given a sorted dictionary. What is time right now? 1:44. Ah, no problem. Just let me take 2 minutes break. Oh, I just want to check how much time I took. I think I took almost 1.3 hours. Sorry, 1.5 hours. So bad. And the reason behind it is simple. Nick Monk, 20 hours AI isn't engineer. I will watch it later maybe. Videos AI is not engineered to watch. I'm watching my own. No, no, I'm not watching. Who is watching? I'm Videos AI is not engineered to watch my own. No, I'm not watching. No. So what I'll do? There should be option to uh, turn on the audio from audience as well. We can collaborate in this one. Like they should add the option collaboration as well. I don't know if there is any feature, but I will take 5 minutes break. I will scroll reels. Then I'll solve problem to get motivation. See my real ID what content I'm consuming. I'll show you. Shamirena. Started Goshwan. So content public. Live Shivangi Chikara. Guitar song. I'll watch. Oh, so what is the wow? If you are using interjection, interjection, yeah. Definitely, I'll subscribe it, bro. बोल मेरा औरा हुआ कब तबाह यहाँ आज भी कायम क्या कॉपी कर someone is commenting the same thing and oh someone is requesting for a song. Dark Past. What is Dark Past? Is it song by what? Dark Past. Oh, song by Mithun. Is it new? I will reply to this one. I don't know.
Thank you, Sergio. Thank you. Thank you. Thank you so much, Suresh. For super chat. Thank you.
She is not. She
Thank you, Janbhai. Thank you, Saranji. Darkhast.
Just
Ashiki
ask.
too, madam. Ashiki too. Thank you, Raji. Will you marry me? No. लगता है अनंत जी सो गए शायद। अनंत जी आप सो गए हो? हमने आपको पसंद का गाना गाया है। आप डांस तो बड़े फास्ट करते हो। क्या बोला?
When she danced,
देख के आ गई है तुम डांस? कैसा लगा तुम डांस? अनंत अनंत जी सो गए हैं। सही
why,
है,
bro?
नहीं सोए।
Let me focus on watching the. I mean, solving the problem. This is the. This is the. This is the. Bro, are you kidding? So let me solve alien dictionary. Given a sorted dictionary of an alien language. Oh, do aliens really exist? Even I don't know. I mean, I'm so sorry. What I'm saying. Even I don't know. No one knows. But we can assume at least. Yeah. Why not? Because if there are multiple galaxies and we don't know what is happening in another galaxies because we are un- we are unable to reach even at a speed of light, and you know what is going to happen if we will be able to make something at a speed of light, will convert into energy. I mean, will turn into energy. E equals to mc square. Mc. PCMC. Given a given a sorted dictionary of an alien language having n words and k starting alphabets of a standard dictionary. Wait a minute. Given a sorted dictionary of an alien language having n words and k starting. Given a sorted dictionary of an alien language having n words and k starting alphabets of standard dictionary. Okay, basically there is a dictionary having n words. What? Find the order of characters in the alien language. Bro, even still I'm struggling to learn English and you are saying alien. To be honest, it looks alien to me as well. Even language, what they have written. Given a sorted dictionary, where is dictionary? How many words are there? 5. Then what is the use? Oh, given a sorted dictionary of an alien language having n words and k starting alphabets of standard dictionary. Oh, sorry. I mean, yeah. So we have an alien dictionary, basically. BAA, ABCD, ABCA, CAB, and CAD. N words and K starting alphabets are being used in dictionary, standard dictionary. Let's see. So, for example, K is 4. A, B, C, D. A, B, C, D, A, B, C, D, C, A, D. So, all the words. Output. There may be multiple valid order. Okay, find the order of character in the alien language. How would I get to know until you want? Oh, okay, okay, okay. Okay. So basically, it's a little complex language as it's alien language. Sorry, just kidding. I will read one more time. I think it's still I'm confused. Sorted dictionary of an alien language. So here you can say this is dictionary, alien language dictionary. There are n words given. These are sorted words, but these words composed of k starting alphabets of standard dictionary. Hmm. So what I'll do, I will just note it down the example. N equals to 5, k equals to 4, and dict equals to BAA. Oh, shit. ABCA. ABCA. Correct? And then CAB. Another one, CAD. So we have this, and let's do one thing. Sorry. So basically, there are five dictionary words of alien language, and these are sorted words. Sorted words in alien language. That means what does it mean? BAA will come before A, B, C, D. That means is B will come before A. Can I say? If both are unequal, that means yeah, B is coming before A. First thing. But if both are equal, hmm, for this one, if you can interpret, 1 minute, I will do this. A B C D, A B C. Oh, what I did? What I copied? Bro. A B C A. Crazy. A B C A. B A A. A B C D. A B C A. C A B. C A D. So these are the things. Okay, I will write down, because if it is normal dictionary, we have to do this in this way. A B C A, C A B, and C A D. So just see. First thing, if both character are equal, then that is okay. Then you will normally what we do in simple dictionary. We'll check first character if when we are comparing these two. So you found that both the character are different. So you can say B is smaller than A. Correct? Now you will compare again this word. Here you can see A is same, B is same, C is same, D is D and A. That means you can get D is smaller than A for sure. Okay. Here you got one relation, here you got another relation, and here you will say again. Now you will compare these two. C A, you will say okay. C and A. That means these two words, two characters. C is smaller than A. Sorry, sorry. Here you will say A and C are different characters. That means A is smaller. That's why it comes first in the sorted vocab. And so you will say A is pointing to C. So this is one thing. Now let's see. Let's compare these two characters. C both have same A B. A and A same B and D. B and D are the different one. So B and D you will say B and D. So B is smaller. Now B is bigger than A. I mean B is smaller than A. So B to A, D to A to C, B to D. So this is an order. If you know, I mean, yeah, it's somehow related to topological sorting, and just need to derive how to derive it. I mean, I will build the relationship here from B to A, C to D, and this B to D. B to A. Let's build a graph. B having relationship with A, and then B is having with D. Okay, then D is having with A. This is a cyclic graph. No, it's not a cyclic. Yeah. So can we say we need to build a topological sorting for it, that B should come first, then D and A. So it will be like B, D, A, C. Oh bro, I will reply to you. Oh, what we sit तुम्हारा मुंह में घी सकते. Oh bro, I will reply to you. Oh, what we sit तुम्हारा मुंह में घी सकते. Just oh bro, I will reply to you. Thanks. Oh, what we sit तुम्हारा मुंह में घी सकते. Just kidding, bro. By the way, let's. I don't know how to say it in English. There will be something. Tamam. The equivalent, the English equivalent of तुम्हारे मुंह में घी सकते is from your lips to God's ears. Oh. See the translation. Ghee and sugar in your mouth. Funny. I think this one is a good one. From your lips to God's ear. I learned it, bro. It's cool thing. Not. I'll keep it in note. Maybe I need to remember it. Sorry. I'm just sometimes. So okay. So we got one thing. VDAC. Not this one. Okay, where is it? Oh yeah, this is here. BDAC, perfect. And three CAAAB. But what if I'm just looking for a word where number of characters are lesser than. Suppose it is like this: B, then A. No, 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 not like this. Suppose it is B. A. Just imagine, like we have BA. Okay, so I'm just assuming another corner case this time. What if we have a language like this: BA and BAA, and the same word appears here: BAAD. Imagine this is a condition. So right now, what if you see in this one, what happens exactly? Every time when I'm comparing, it ends before it. For example, B, we got at the first character comparison, but it could be, it might be, when you are comparing two words, there are multiple scenarios. It's not like every time you will get equal word length. So for example, it could be BA and D. This is one scenario where you got only one character different. So this is okay. Here you will compare first character and this will mismatch if the length is equal. But it could be, so this, sorry, this is one thing, and another one it could be B A B A D. Then what you will do? You will say, oh, both are equal. This is equal. So what should I compare here? So I'll keep D as an independent node as of now in the graph. There won't be any adjacency between D and A. Correct? Let's think about the character comparison. So this is my thought process, and after that, once we'll build the adjacency list, it's like you have to use topological sort. But just I'm wondering if it is the only thought. I mean, yeah. So let's think. There are two words. Word 1, word 2. Now we are comparing. So what I will do? So suppose here you have given these words. So every time this is like A, this no 1, 2, 3, 4, and 5. These are the index, or you can say these are the words. So what I will do? You will just pick one word and you will compare it with the next word. So here for 1 you will compare with 2, for 2 you will compare with 3, for 3 you will compare with 4. I mean like this. 1 you will compare with 2. Okay, so this is one thing. 2 you will compare with 3 again. So you will build a relationship between these two. 3 you will compare with 4. So you will get one more character if required. Not required, but you definitely, damn sure you will get one character. Uh, could it be? I'm just let me think. Five. So here you will get another. But imagine it's a solid, and in programming you cannot say that everything will be smooth. It could be BAA, then ABCD, and there is another ABCD because it is still sorted, right? Oh, sorry. Let me just read the language. Given a sorted language having n words and k starting alphabets of Western to find order of any valid order. Hmm? Inconsistent. What is the use of k here? Something. If given arrangement of words, if the given arrangement of words is inconsistent with any possible later ordering, return an empty string. I'm not sure what is this one. What exactly it is telling? How can we get inconsistent? And what is the use of k? Because, and also I haven't checked the constraints. N means there will be 300 at max. K 26 letters. A to Z. A to Z. People say Z instead of Z. I also started. Sometimes G, sometimes Z. Zebra. By the way, BTW. And 301 K 26 dictionary length 1 to 50. Wait a minute, what is dictionary of I dot length? Okay. Oh no, I have doubt. Case 3. If they won't tell us like it's okay number, if number of characters here, definitely for sure there should be 3 only distinct character, maximum 3. For example, here C A A B. I'm just thinking, what is the use of K in this uh, problem? K definitely will help us to find out. So might be there are more than these unique characters you can say. So I will compare that as well. Like if there is more than K number of, then you will return false. as a string I need to return, right? So one thing I'll do, first I'll compare check. Suppose there is a AB and another string is A. Oh bro, hi. Sorry, I'm not looking all the time. Sorry. Maybe I'll just check. Hi bro. Okay. I have one edge case where how to topologically solve it. Here A is same in both. Logically it should be like A should come first then B. Yeah, so what I can do, I can replicate A. That means at least there will be A should come first before B from this language. You can say it, right? Just need to think more on it. Can it be A, suppose A, B and A, sorry, no. Let's say one more corner case I'm taking. Imagine this is like there is a word A, B and there is one word A, B, C, D and these are the words. So K is 4 and suppose we have only these three. Okay, let's say these two examples. So what should be the there? So can I say A are equal B? So there won't be any graph between these A and B. But for sure, after that, you can say should be C and D. There isn't any perfect. Yeah, so I'm thinking too much about corner cases. I don't know why. Okay, A B B C D. Here I think I need to make like A should be A to C. There should be A to D. There should be B to C. There can be B to D. A to C. A to D and B to C. B to D. What kind of graph it is? So basically A and B can be anywhere, A and B, C and D can be anywhere like this. Suppose this is one of the graph and you have only one character. So what you will do, you can I can create lot of adjacency at edges. For example, here it should be B to D, A to D, and another A to D that is not relevant. So B and A can be anywhere, and after that D should be there. But what if I won't do anything? I need to create edges. Oh god, I'm taking a lot of time to solve it. Yeah, bad, bad, bad. Sorry, I feel what I feel. Nothing. Here. Okay. What I'll do, I just need to create adjacency. After that, it's just quick. Okay, imagine I just want to create all the adjacency edges. I mean, all the edges. So, how to start it? Suppose there is a word one. Let's think about it. There is a word one, and there is word two. Sorry, I just need to keep it here. So there is a word one, word two, and they have different length. Irrespective what is length. So you will start comparing from starting. You will go and you will keep the length equal. So here you will say first character. If it is matching, then you will simply do nothing. Second character. If it is matching, you will do nothing. Third, matching, you will do nothing. Fourth, not matching. I mean, it's part of one. Then you will basically call all the edges before it. Oh, all the characters before it, distinct characters, you can say, and you will create an edge between these. And similarly, if there is another E as well, then you will create edges from D to E. Okay, so we can do this, but approach. There could be different words. Why don't I do, if I'll take min length, I'm just thinking about optimization. And what I'll do, suppose BAA and BAADE. Let's say this is one example. So what I'll say, this is length of it M, it is length of N. So I'll check, this is the last, if M is less than, first primary check, what I'll do, simply I will compare the last character of it with the same character. For example, here it will be M minus 1 index, and here also if word, word, M minus 1 equals to word 2, word 1, word 2. So I'm just checking last character of this array with the last character with the at same position, what is the last character. So you will check this one and you will compare both. If both are equal, that means okay, everything in this one and this one is equal. So then apply this rule. Basically you will start from here, and what you'll do, for each age, for example B to D, there will be an age. So what you'll do, you will add it into this. Similarly, A to D will be there an age, and another one again A to E. So you will check whether it is already part of the adjacency list. If then you won't add. And similarly, again you will do this one. Up again you will perform the same for the another remaining one, E. A word length can go up to 50. Okay. So that is okay. In this way I will be able to create. Let's dirty our hands. I was sharing, is my screen or not? Yeah, I was sharing. This is one thing. What are the submissions? Editorial solution one on. So I'll do one thing. Build the adjacency list. So adjacency. Okay, I will do one thing first. Create char to index map. So D, basically char map I in range K, and so we are terminal. I need to explore it. Char of 0 A, sorry, CHR, no, I'll just read archive value to character str here. str of 67. Oh, sorry. Hmm, perfect. So I think it starts with 97. Wonderful. Okay, so 0. So what I'll do, simply I will map it like in this way. So chr of 97 plus I mapped to, okay, map to I. Will it work? I don't know. I forgot the dictionary comprehension Python terminal. A0, B1, C2, 3, 4, C9. Perfect, bro. This is working. Dictionary comprehension. First thing I will do this. Second, once I create a dictionary comprehension, then next thing is simply I need to work on what? Oh, actually, I need to prepare for Snowflake and DVD, and I will end with this after it. How many questions I solved today? I think I just solved one only. Fuck. Create clear map index and then just do, let's define uh, com build adjacency self word one. Oh, again I did one. Word 2. What I'll do, m is equals to len of word 1, n equals to if word 1 and word 2 are equal, then that is okay. There will be two chances only. It cannot be like one is having more. So either m will be lesser or it will be equal. If array of m minus 1 equals to no word of, I mean just word 1 of m minus 1 equals to word 2 of m minus 1. If both are equal, need to create adjacency for, okay, I will just add one more thing, adjacency adj, each Else, if it is not the case, it means you are in the safe zone. Then what you'll do, simply you will start I in range M, and you will do what if word 1 of I not equals to word 2 of I. If any word is not equals to if this is a condition, word 1, word 2. So what I'll do, simply word adjacency of word of I, word 1 of I is equals to dot append, no, oh sorry, I'll say I will pass character map as well, char map. So here I will just use, I'm just creating adjacency of numbers indexes. So char map of word 1 of I is equals to char map of word 2 of I. So A to B you are mapping, like the word that is not matching. Okay, and then after that you don't need to do anything, just break up. I mean break, not break up. By the way, need to create adjacency for each. Yeah. Okay, so what I'll do, so for each word we need to create adjacency. For each character, what? So what we'll do, for I in a range M, so each character, and yeah, better, I'll do like this. For Z in a range, basically you will start from M to N. So these are the range of the characters that are extra characters in this one. And what you'll do, if for example, if so you need to match basically word I, this character, with J, word I to J, there will be an age I to J, correct? I think it's better if I'll use I to J, it's pretty intuitive. If I'll use it upper and I'll keep it here. Now if I word 1 of I, so first I'll basically what I'll do, I'll map. So let's say node 1 will be char map of word 1 of I, and node 2 will be char map of word 2 of I, Z, yeah. So for Z, so you got node 1, node 2, and now you want to make an edge. If adjacency of node 1 I to j. If node 2 node 2 not in, if it node 2 is not part of adjacency, then you can append it. Then node adjacency of node 1 dot append node 2. Yes, yeah, that's all. I hope I covered all the corner cases. Perfect. Sorry, I'm taking a lot of time to solve this problem. Let's build adjacency. Build adjacency. Adjacency. And now what I'll do? Adjacency will be something like this for underscore in a range k. These are the characters. For each character there will be something mapping, and it could be or it could not. Now you'll do one thing. For not for build self dot build adjacency, and here you will pass. No, it won't. For word in no, let's do one thing. Range n minus 1, because last one. And now you what will do? Word 1 will be basically dict of I, and word 2 will be dict of I plus 1. Okay, now you will say build self dot build adjacency word 1 word 2 and adjacency char map. So you have given this. Now you will be having build adjacency. So just print. Okay, let's write complete solution for it. So we have this. Basically we created graph, and now next part is apply DFS. Apply topological sorting. So what I'll do, for k in range I in range k, if k not it's like this stack. So if k is and will mark visited is equals to 0 for underscore in range, this is simply topological sorting range k. K is if k is not k not if not visited k. So sorry, I will keep it node. So you are calling node and you will say visited adjacency, node adjacency visited. So this is one thing, and at the end when you have finished stack dot append, I don't know why I feel like I will forget it. Node, and let's build define self DFS depth first search self. Here you will say node and adjacency visited. Also you will pass stack, don't forget. So for NBR in adjacency of NBR node, what exactly we are doing? So you are exploring all the neighbors. Now you will say if not visited of neighbor, if neighbor is not visited, then simply you will say self.dfs and neighbor. So for this it's going to explore all the options available for this neighbor, from neighbor. Okay, so that is going to be done. Neighbor adjacency visited and stack. At the end what you will do, stack dot append and you will say neighbor. Perfect. And at the end, that's all. You will call this stack dot append var is not visited stack dot append, and at the end you will get a result stack. Stack is just, we need to reverse the stack, because top one is going to be pop. Once you will pop out everything, top one will come first. That means you visited last, it will come first. So stack is equals to stack, no, let's change the name. Result is equals to stack dot reverse that it will work. Okay, now we got result. And now one more thing, fin result will be for I in range, no, for R in result, you can say node in result. Basically what you have to do, again you have to do this. I don't know why I feel like some mistakes will be there. My screen is visible or not? Yeah, it's visible. Woohoo. BA, then M less than M. What is the use of character map? No use, bro. Hmm. Oh, bloody mistake. Terminal. I don't know. I feel like it will fail. Crazy. Drop it, bro. Maybe. Let's do one thing. For this, I will get some idea. Adjacency list. Let's build. Before returning or something. Let's see what is problem here. We have something like this. It's going to compare A with A, and first character only won't match A to B. Advanced, however, build adjacency is still incorrect here still. If length of M and N is equal, I think it's done, bro. I won't be able to do it right now. I need break. Let's stop it here as unnecessary. I'm just wasting time.